Hi friends, welcome back. Today we're talking about complementary and supplementary proofs. Now, I'm going to give you a ton of information in this video. I expect that you will write these things down in your notebook because they are extremely helpful. So first things first, we're going to talk about complementary and supplementary proofs. I'm going to give you a bunch of definitions and usage of these terms, and then we'll revisit those as we do these proofs. So the first thing we're going to talk about are these right here. Pause the video, write these down so that you have them. And what I mean by these is definition of a right angle. If you see 90 degrees or right angle, they're interchangeable. Definition of perpendicular lines, if you see perpendicular, it's interchangeable with right angle. So you cannot do perpendicular and 90 degrees, you have to do perpendicular and right angle. That'll make more sense in a minute. Complementary angle theorem. This says that complementary angles are right angles. If you have two angles that are complementary, they're right angles. Definition of complementary angles says that complementary angles are 90 degrees. Definition of supplementary says supplementary are 180 degrees. Linear pair theorem, aka supplementary angle theorem, says that linear pairs are supplementary, and vice versa. Now, this may seem repetitive. I have complementary angle theorem and definition of complementary angles. Lots of kids get those mixed up. So I want to give you some examples here. When we look at these guys right here, if you are given this information, then you can make this statement for this reason. Now, keep in mind that these guys all the way down are interchangeable. So this is interchangeable with this is interchangeable with this is interchangeable with this, and this is interchangeable with this. What I mean by that is if you're given, or if you've previously said angle A is a right angle, what you can say then is, well, then angle A must be 90 degrees because of the definition of right angles. If you say that x plus the measure of angle x plus the measure of angle y equals 90 degrees, then you can say, if you've said that somewhere before or you're given it, you can say angle x and angle y are complementary. Or if you have said, hey, angle x and angle y are complementary, that means that they also equal 90 degrees. That is the definition of complementary angles. Now, let's talk about this here, down at the bottom here. X and y form a right angle, therefore x and y are complementary, and vice versa. Those are the complementary angles theorem, saying that if angles are complementary, they form a right angle. Then you say, after you say that you've formed a right angle, then you say, if these have formed a right angle, then we come up here and we say, okay, that must mean that these guys together are 90 degrees because it's the definition of a right angle. So this seems kind of confusing right now, but I think this is a really helpful chart in order to understand why you have to prove things the way that you do. Now, the neat thing about proofs is that no, you don't have to do them the same as all of your classmates or even as your teacher. You just have to use your statements and your reasons. There's got to be good reasons in order to do that. So what I want to do now is do our first proof here. And so go ahead and take a minute, copy these down, pause the video if you need to. Okay, so angle 1 and angle 2 form a linear pair. Angle 1 and angle 3 are supplementary. Okay, so what that means is the very first thing you want to do is just write down your givens. That's the easy thing, right? All right, angle 1 and angle 2 form a linear pair. Now, let's go back to our notes here. I want to talk about that linear pair one for a second. Remember, linear pair means that they are supplementary. I can't just say, hey, these guys equal 180 degrees. I first must say that those linear pairs are supplementary. So I see that linear pair right there. So what I'm going to write then is angle 1 and angle 2 are supplementary. Okay, and I'm able to say that because the linear pair theorem, or you can call it supplementary angles theorem. So linear pair theorem. Okay, now that I've said that, you can see that I have two things here. I have angle 1 and angle 3 are supplementary, and angle 1 and angle 2 are supplementary. Now, for step 3, what I can say is the measure of angle 1 plus the measure of angle 3 equals 180 degrees. Then I can say the measure of angle 1 and the measure of angle 2 equals 180 degrees. So that is this guy right here and this one right here. You'll see the supplementary. If we go back and we look at our chart, right, we are looking for, all right, so we're looking for supplementary to 180. Supplementary to 180. That is the definition of supplementary angles. So we come over here and we say definition of supplementary angles. I'm kind of abbreviating here so you don't have to watch me write. Okay, so now that we have said that those two things are 180 degrees, and we did that because we did you always want to do your definitions first in your proof. If you've got words, then you probably have to define them. So our next step after we've done our definitions is to say, well, hey, if this garbage equals 180 and this garbage equals 180, let's just say those garbages equal each other. The measure of angle 1 plus the measure of angle 3 equals the same as the measure of angle 1 plus the measure of angle 2. Okay, so why can I say that? So number 4, why am I allowed to say that? That's because we have this, we've kind of kicked out this middleman here. That's called the transitive property. We've said, hey, this garbage equals 180, this garbage equals 180, therefore the garbage equals each other. That is called your transitive property. Transitive. Now, looking at this, and I still haven't even gone back to look what I'm proving, but you'll see that I'm trying to prove angle 2 is congruent to angle 3. So I come over here and I see, well, I have measure of angle 1 here and here. If I minus measure of angle 1 minus measure of angle 1 here and here, I end up with measure of angle 3 equals the measure of angle 2. And that's from subtraction. Subtraction. Okay, now I realize I just made a tiny mistake here because I'm trying to prove angle 2 is congruent to angle 3, and you'll see that I have angle 3 is equal to angle 2. I need to flip those guys around. That's called the symmetric property. So I'm just going to say, okay, measure of angle 2 equals the measure of angle 3 because of the symmetric property. I can't spell and talk at the same time. I don't know why. Okay, so now I'm really close to saying angle 2 is congruent to angle 3. All I got to do here is just say angle 2, so my 7th step here, I've got angle 2 is congruent to angle 3, and that is just the very definition of congruence. You will come to love definition of congruence because you're going to use that all the time. Definition of congruence. So now I have proven it. Kablamo, awesome, there we go. Let's talk about our next one. All right, so our next one we have is this guy right here. So take a minute, pause the video, write that one down. Okay, so the first thing we're going to do is, so angle 1 and angle 2 are complementary, angle 3 and angle 2 are complementary. Okay, remembering on our notes that if we want to go from complementary and we want to say that they're equal to 90 degrees, that's going to be the definition of complementary angles. So we say, okay, the measure, well, first we write down our givens. Always do your givens first, free points, right? So that must mean if they're complementary, go back and look at your list and you're like, okay, complementary can mean right angles, it can mean 90 degrees. I think it's going to be more helpful for us to say 90 degrees here. So for number 2, we're going to say the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Also, the measure of angle 3 plus the measure of angle 2 equals 90 degrees. And that is because the definition of complementary angles, Okay, so now that we have those things, just like in our previous one, we can say, hey, this garbage equals 90, this garbage equals 90. What we can do is say, all right, well, the measure of angle 1 plus the measure of angle 2 equals measure of angle 3 plus the measure of angle 2. That's because what we did is we said, hey, this garbage equals 90 degrees, this garbage equals 90 degrees, therefore they have to equal each other. That's, I cut out that middleman and just set them equal to each other. That again is the transitive property. A lot of kids get confused between the transitive and the substitution. So transitive property. But if you can cut out a middleman, it is transitive property. All right, now that I have this, what I can say is the measure of angle 1 is equal to the measure of angle 3, because if I minus angle 3 or minus angle 2 from both sides, I get 1 equals 3. So that is the subtraction property. Okay, for my final step, so remember I'm trying to prove angle 1 is congruent to angle 3, and I'm real close to being there. This is where you're going to use your favorite one again. Number 5, we have angle 1 is congruent to angle 3, and that is because of the definition of congruence. And so now I have proven that. So that is how you do those complementary, supplementary proofs. Take a look at those notes again. Make sure that you can access those, copy those down so you have them. I look forward to seeing you next time. Have a good one. If you have questions, let your teacher know.